Hi, I'm Mr. Huber, and in this video we're going to talk about problem 7g. You see, we have a factor in front of the brackets. That means it's a sad parabola because it's negative, and it will be a vertical stretch. So everything will be multiplied by -3. Okay, let's start this off. F of x is x minus 5 squared plus 16, and the -3 in front of it. Good. Now, well, it's clear that at 5, it will be 0 here, times -3 plus 16, so that's going to be 16. That's the vertex. Well, we know the vertex is 5, 16. So it's in fact a parabola that has been translated to the right by 5 units and 16 up. Then you know, normally x squared means 1 to the right, 1 up. So something like this. Then f of x is 3x squared, would mean 1 to the right and 3 up, 1 to the left and 3 up. So this would be a vertical stretch. Okay, so you can't see it on my drawing here because it's just a qualitative drawing. But then f of x is minus 3x squared. That would look somewhat like this, and it would be a vertical stretch as well. Okay. So you can't see that on a qualitative sketch, but we know it's 1 to the right, and instead of 1 down because it's sad, it's 3 down because we have to multiply everything by -3. Same thing over here because it's symmetric. Now 2 to the right, and it would go 4 down, but we have to multiply it by -3, the whole thing. So that's in fact 12 down. Here we go. And same thing over here. Now, 3 to the right, normally it would go 9 down, but because of the factor -3, it's minus 27 down, so 3 times 9, so that would be down at 11. So here, -11, okay. So if you draw this graph, and the points are fairly far apart, so it's quite difficult to draw a good and smooth parabola, but we're doing it as best as we can. Here we go, more or less a smooth parabola, a sad parabola. Okay, it's not perfect, it's far from perfect, but it's a good drawing. It's quite accurate because we have plotted 1, 2, 3, 4, 5, 6, 7 points, okay? So it's not just a qualitative sketch. Obviously, you could fill in a table. Well, let's just do it at 5. Well, that will be 16, that's clear. Then 6, and here 4, 7, 8, 3, 2. Well, if you plug in, let's say 6, that will be 1 times -3 is -3 plus 16, so that's 13. Look, we're at 13. Could do the same thing with 4. Let's do one more with 8. Look, that's 8 minus 5, that's 3 squared. That means it's 9 times -3, that's -27 plus 16, that's -11. Okay, -11. Well, if you do it with the 7, let's just do that too. 7 minus 5, that's 3. 7 minus 5, that's 2, sorry. Squared is 4, so times -3, that's -12 plus 16, so we will be at 4. And as you can see, we're exactly at 4 here. Now look, this is a fairly accurate drawing. Obviously, my graph is not perfect, but it's quite accurate because we worked out 7 points. But if I had asked you to just give me a qualitative sketch, you would probably have done something like this. You would have said, well, this is 5 and this is 16 because that's where the vertex is. And then you would have said, well, our graph is looks somewhat like this. It will be a parabola, a sad parabola. But what we have not taken into account now, the vertical stretch, you can't really see it if it's stretched or not. But as an overall first impression of the graph, it's quite good because we know the vertex is at 516 and it's a sad parabola. Clearly, this is more accurate. But well, if I ask you to give me a qualitative sketch, then that would be enough. If I asked you to give me a quantitative sketch, well then I would mean something like this. For the moment, we're doing quantitative sketches because it's quite simple here with this exercise. So I hope it wasn't too difficult. See you in the next one.